All right, let's jump right into this explainer. Have you ever stared at one of those sleek, ductless mini splits quietly hanging on a wall and wondered, how does this one tiny box conquer both the dead of winter and the peak of summer? Well, you're in the right place. Today, we're unpacking the exact mechanics of four-way reversing valves. We're going to break down the brilliant engineering that makes this dual comfort possible straight from our source material.
It's kind of the ultimate climate control paradox, right? How on earth can one single machine both freeze and bake a room? Well, to really understand this modern comfort magic, we've got to look past the plastic vents and fan blades. We need to look directly at the hidden mechanical hero doing all the heavy lifting inside that mini split. It's an incredibly elegant piece of engineering that literally turns our traditional understanding of heating and cooling completely upside down.
Section 1. The mini split secret. Unlocking its dual nature capability. So, here's the secret. The absolute crucial point is this single mechanical director, called the four-way reversing valve. This component is the literal turning point for the entire system, dictating whether you're going to be shivering or sweating. And it does this by literally changing the direction of the refrigerant flow. Now, it's vital to grasp what that actually means. See, this valve doesn't magically generate heat or cold out of thin air. Not at all. Instead, it acts as a master traffic controller for the thermal energy that's already moving through the system. By just acting as a gatekeeper, it decides if heat is being absorbed from your room or dumped right into it. It's a total paradigm shift. We aren't burning fuel to create heat anymore. We're just telling the existing heat where to go. And it's all thanks to this one critical component. Moving on to Section 2, Anatomy of the Valve, a look inside the outdoor unit. Okay, let's look at the core anatomy based on our source data. Think of this valve like the ultimate switch track in a giant train yard. You've got the sliding piston, sometimes called a slide block, which physically moves back and forth to shift the tracks. But it doesn't move on its own. That tiny solenoid pilot valve you see, that acts as the conductor. And honestly, this is where the engineering gets truly brilliant. The solenoid doesn't just push that heavy slide block with sheer magnetic force. No way. Instead, when it gets an electrical signal from your thermostat, the solenoid opens up this microscopic port. This tiny, tiny opening instantly creates a massive pressure difference inside the sealed valve chamber. It's actually that intense pressure differential, the built-up force of the refrigerant gas itself, that physically shoves the larger sliding piston across the chamber to its new position. And of course, the compressor is the engine here. It supplies the hot, high-pressure gas that travels through these tracks, providing the muscle necessary to make the solenoid's pressure trick actually work. Section 3. A tale of two modes, cooling versus heating. So, in cooling mode, the valve acts as a simple one-way street in its default unenergized resting position. It naturally takes the hot, high-pressure gas generated by the compressor and directs it straight to the outdoor coil. The entire goal here? Just dump that heat outside so your room stays perfectly chilled. I mean, this is basically how standard air conditioning has worked for decades. The heat from your home is absorbed by the indoor unit, it's compressed into this high-pressure gas, and the reversing valve confidently points it to the great outdoors to be released into the summer air. As long as your system isn't asking for heat, that slide block just sits perfectly still, allowing the standard flow of refrigeration to keep you nice and cool. But what happens when the seasons change? Well, when winter arrives and you switch your system to heating mode, the magic happens in 3 distinct chronological steps. First, that small solenoid pilot valve energizes with a quiet, decisive click. Second, just like we talked about, that electrical energy opens the tiny port, creating an immediate and powerful pressure imbalance. You can almost imagine the sudden rush of force inside that copper casing. The sliding piston physically shifts its position, slamming into its new alignment. And let me tell you, rerouting hot gas is a massive physical achievement within a sealed, highly pressurized system, but this valve handles it flawlessly. Third, because that slide has shifted the internal tracks, the exact same hot, high-pressure gas coming from the compressor is forcefully rerouted. Instead of heading outside to the summer air, it gets sent directly, and I mean straight to, the indoor coil. The train has completely changed directions. Looking at these pads side by side really highlights the genius of this design. In cooling mode, the heat goes out. Easy enough. But in heating mode, rerouting that hot gas effectively turns the indoor unit mounted on your wall into a condenser. Just let that sink in for a second. The indoor unit, which normally evaporates refrigerant to cool the air, is suddenly completely transformed. It takes that violently hot, high-pressure gas and releases its heat directly into your living space. The physical mechanics of the four-way reversing valve completely flip the function of the indoor and outdoor coils.
Your outdoor unit becomes the evaporator, pulling whatever trace amounts of heat it can find from the freezing winter air. And your indoor unit actually becomes the condenser, radiating that amplified heat straight into your bedroom.
Section 4. Comfort and efficiency, the everyday benefits.
This quote from our source material really just hits the nail on the head. This simple reversal of flow eliminates the need for separate heating and cooling systems. It truly is awe-inspiring when you stop and think about it. This simple mechanical movement of a slide block, directed by a tiny energized solenoid manipulating invisible gas pressures, is the exact thing keeping you comfortable in both December and July. By simply putting the whole system in reverse, the requirement for a completely separate, dedicated heating infrastructure just vanishes. You are, quite literally, heating your home with your air conditioner.
Because the ductless mini split leverages this four-way reversing valve to do double duty, the end result is a highly efficient, space-saving system. You get year-round comfort, and you don't need a basement full of separate appliances. I mean, think about what used to be required to pull this off. You needed a massive, noisy furnace dominating your utility room, an absolute maze of separate sheet metal ductwork just for winter heating, and then a totally separate standalone AC unit sitting out in your yard for the summer. Now, it is a streamlined, compact solution made entirely possible by cleverly manipulating the direction of refrigerant flow. It's a real testament to how doing more with less is absolutely the pinnacle of modern engineering. So, think about the elegance of this engineering and what it really means for the future of home comfort. We are looking at a total paradigm shift, all driven by a single sliding valve and its clever solenoid conductor. As we move towards smarter, more efficient, and more compact living solutions, you really have to wonder, is the traditional bulky basement furnace living on borrowed time? Will this compact flow-reversing technology eventually make those old systems completely obsolete in all homes? It's a fascinating question to ponder as we watch this tech continue to evolve. Thanks for joining me for this explainer, and hey, I hope you never look at your wall unit the exact same way again.